Today, we're still on module 2, Boolean Algebra 2, lecture 5, 4. As far as I remember, there was no question. I saw on the canvas, there are one, I think on the module 3, just hold on, let me take a look. Discussion. Yeah. So these are from Alexander Wolski. These are good question, Alexander. Let's take this question in next class. Let's other catch up to the module 3, and let's discuss this on this coming Monday.
All right, sounds good.
Okay. So far, like on today's topic or anything from previous lectures, if you have any question, please let me know, or any other discussions that you want to bring up.
Hey, Professor?
Yes.
Hey, Professor, can you hear me? Oh.
Yeah.
So we heard contradicting reports on whether it's the second take of the quiz that gets recorded as your final score or your best take.
I think the last, just hold on, let me quickly check. Why don't I quickly check on that?
I mean, ideally, they should both be the second one, of course, but like, say you get one right the first time, and then somehow, I guess you see which ones you get right, so that shouldn't really happen. I guess it's not.
Right. My assumption is always like, yeah, it's basically a score to keep highest.
Okay, and it should be the second one anyway, so yeah.
Yeah, I think someone I replied it is a latest one, but I see in my setting I keep it as an highest. So it is highest between these two.
Okay, cool. Thank you.
Yeah. Let me see if the other quizzes also has the same setting. Or is it just a coincidence that I did it? Yeah, I think it is. I kept is the highest one. Yeah. But your scenario can still happen, right? So you have a highest, but in the other set, you got the answer right. In that case, I would recommend you to just communicate with me. I need to do some manual job there. Okay, so if you see that in one set, like one attempt you have a wrong, and that attempt had a, no, how is it? The attempt you got a highest score on has one question wrong, which actually was by mistake. You made it right on the previous one. So in that situation, just communicate with me if that happens. But it is unlikely because you will be, at least able to see which one you got wrong and which one you got right. Okay, so we were like till today, we are learning, and practically these are reviews from your CS47 or previous study, Math 42 equivalent. These are all logic, algebra review. Does any one of you actually know about this K-map before? Karnaugh map? Was it taught in the Math 42 or other classes? If anyone can share that experience.
Not in Dianza's prereqs, which are the ones I took.
Okay. Yeah, there is a discrete math prereq, right, for this course. So nothing about logic was taught in the Dianza?
Definitely logic, just not K-map specifically.
Okay. That's what I thought. Yeah. So how about others, like other institution? Anyone want to share the experience? Akash, you are mute.
Oh yeah, I was just gonna say I took it or learned it in your CS47 class, but that's about it.
Okay. Yeah, so this K-map is more related to the digital world. So I was expecting that at least the CS47 or equivalent, those courses would cover that a little bit. But nonetheless, this is a review and you can learn it now. It is not a super like a rocket science thing to learn about the K-map and how to use that and utilize it. Let's do an example. I'm sharing my Jamboard with you. And then let's see. So there are some people who are, okay. Let me admit other people's too. I didn't realize some people are waiting on the waiting room. Just hold on.
Oh.
Yeah. Okay. I hope like this is 81 good participation. From now onwards, I will keep the waiting room on so that like if you join late, you probably need to wait a little bit till I realize someone is waiting. So please try to make sure you join like at least like couple of minutes before and wait in the waiting room so that you don't miss anything. Today probably you haven't missed anything so far. We didn't have any um, theoretical conversation. Okay, so I'm sharing the Jamboard. Let's do one example of K-map. So the example is something like this. Let's say I have given a function, Boolean function with, let's do it 4 variable, w, x, y, z equals sigma m 5, 7, 12, 14, plus it has some don't care terms, which is 0, 2, 13, 15. And now, first we start with drawing the K-map, right? This is a 4 variable, so it will be like 4 by 4. There will be like 16 cells in this table. So we draw a square, divide into 4 equal part, both ways. And let's go with like marking. This is for these rows are for variable wx and columns are for variable yz. Let's mark that way. And also let's put indices on the rows and columns. So how do we put indices? We put indices in binary, but in a gray code sequence. That means one bit will change at a time between columns, like 0, 0, then it will be 0, 1, then it will be 1, 1. Just so at like when we transitioning from column 1 to column 2, it is 1 bit change, and then column 2 to 3, it's a 1 bit change. And similarly from column 3 to 4, it will be 1 bit change. Okay. And similarly for the rows, we make 0, 0, 0, 1, 1, 1, 1, 0. So that's how we put indices on those rows and columns. And then let's make, like this is for like making an easy manipulation. Just put the decimal indices on these cells. Like for example, so we combine row and columns 0, 0, 0, 0. So that become 0. Then we combine row 0, 0, column 0, 1, right? That becomes 2, sorry, 1. Then we combine 0, 0, 1, 1, this one. That becomes 3. And then we combine 0, 0, 1, 0. So that in decimal it is 2, right? Similarly, we combine 0, 1, 0, 0, which is like 4. Then it is 5. This is 7. This is 6. Then this is 8, 9, 10, 11, 12, 13, 14, 15. So we basically put the index number onto each of the cell in this table. Okay, so that's how we construct this 4-variable K-map table. Any questions so far? All right. Now, now we look at this function. Look at this function. Like this is a summation of min term 5, 7, 12, 14. So we basically put 1 in those cells. So that means cell C1, sorry, C5, C7, cell 12, and cell 14 will be marked as 1. So cell 5, cell 7, cell 12, and cell 14. And for those don't care term, we'll mark those cell as X. So C0, C2, C13, and C15 will mark it as X. So C0, C2, C13, C15. Now we start our group combination process. So initially, we start with grouping, just try to group with a 1, okay? So as a step. So maybe this is 5, 7. So cell 5 and 7 can be grouped together because they are adjacent with each other, they neighbor with each other. And also group 12 and 14. They are also adjacent with each other. Now, at this point, we ask ourselves, can we increase the group by including more cells? And in that process, we can include the cells with X. So you see the difference with the X and the 1. 1, we deliberately try to group them. And X, we group them only if it helps to make a big group. And in that big group, you need to have at least 1, 1. You cannot group all X's. That doesn't make sense, basically. Okay, so group, make a bigger group using X. So that means you actually have a bigger group like 5, 7, 13, 15, this one, and 12, 13, 15, 14, this one, each of this group of 4. So that means we actually don't need to consider this one or this one. This is not needed. This is not actually contributing to anything on these making the groups bigger. So far, so good. Question?
So sorry, you might have mentioned this, but if you did, I missed it. I don't know if that symbol is supposed to be a D in front of the don't care list or whatever that is, but the don't cares, is that related to the max terms if the small m is the min terms?
No, don't care is not related to max term. Don't care will it basically says that let me try to explain in a different way. First of all, don't care is not a mathematical concept. Okay, it is more coming from the digital logic design perspective. Okay, so in the digital logic design, our requirement spec can be something like this. Like let's say I need to design something, some circuit CKT, with some Boolean function that will realize like maybe 3 functions and 2 output. So I0, I1, I2, and they have 2 output, just as a requirement. And this requirement specification says that I expect the bit combination between I2, I1, and I0 as 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1. Just from the spec, right? So this means what? This is like M0, M1, sorry, M2. This is mean term 2, this is mean term 3, this is mean term 4, and this is mean term 7, right? So by the specification of the digital circuit to be designed through this logic optimization process, we have these valid mean terms, which may be like your function may be like output 0, maybe like this is 1, this is 0, this is 1, 1, 0, and oh, sorry, I'm out of column. Maybe let me write down output 1. So this is 1 is done. Output 1 is maybe for those is 1, 1, 1, 0, 1, something like that. It doesn't matter for our understanding. What is more important to understand that from the specification, what circuit we need to do is basically to which expect this mean term incoming on the input side only. That means for a 3-variable Boolean function, this one is I2, I1, I0, I0 equal to sigma. Let's pick up for the output one, right? M0, M3, M4. Okay. So these are the contributing term, M0, M3.
And the don't cares would just be the ones with 0. So 2 and 7.
No. Don't
No?
care would be like whichever term is missing from the thing, right? Don't care term will be M1. M1 is not in the spec. See, 0, 1. 1 is missing. 2, 3, 4, 5 is missing. 6 is missing. They are don't care term.
Got it. Thank you.
Okay, so it is purely a digital circuit design conception. It is purely a digital circuit design conception. So, but in the math world, this situation doesn't happen. Like it always talks about the full spectrum of all the mean terms, and if one is 0, other is 1, and stuff like that. Only in the digital logic, we deal with the don't care term, and it's purely coming from the circuit specification point of view. Okay. So that's why like making like something like grouping all excess, like here, for example, if you want to make this group, this is wrong because, like your circuit is never expecting some input to there, right? On these two mean term. So you're unnecessarily adding extra element onto your circuit. That's why group with all excess is not needed or is not recommended to make with when we deal with the don't care term. All right, now how we write down the function now? Function has this concept of prime implicate or PI. PI is that maximal group. So for this case, it has two primary implicate, this one and this one, right? And we write down like this primary implicate in terms of like that's compact SOP notation as like 5, 7, 13, 15. And another prime implicant is 12, 13, 14, 15. Okay. So practically this means this function is nothing but an odd between mean term 5, 7, 13, 15 or mean term 12, 13, 14, 15. Now, how do I write it in terms of these variables? That is the question, W, X, Y, Z. So we look at the group. Okay, so let's pick up this group first, 5, 7, 13, 15. And we look at first this group's row. Look at the row. And in this row, now see which variable's value is constant. Means, like, let's say if you are picking up, looking at this value, this one belongs to this W and this one belongs to X, right? So that means we see that in this group, X is constant at 1. This belongs to X. But W is varying. The W is varying. W is, for one row it is 0, other row it is 1. But X is constant at 1, so we pick X. And now we look at the column. For the columns, like the first one belongs to Y, second one belongs to Z. So this sequence is really important. So you need to make sure you maintain the sequences, WXYZ, WXYZ, etc. Otherwise, in the process of doing optimization, you may get confused and get a wrong result. So it's better to practice with the right sequence. Now in this sequence, we see that Z is constant at 1. Y is changing. Y is one column, it is 0, other column it is 1. But Z is not changing. So we write Z out of that. Okay. And now come to the other, this one, 12, 13, 14, 15. So what we do, we see that in the column side, it's already like everything is changing between the column. Y is also changing its value. Z is also changing its value within the column. And constant is both W and X at 1. So it becomes XZ or WX. Question? Okay, now let's take one more example from here in the part where we actually, the inversion will take place. Okay, so let's go to the other part. Let's draw an arbitrary function. Okay, maybe we'll just reuse this one. Okay, maybe we'll use it. Let me first draw that. Just hold on. Okay. 4 by 4. Zero 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 one 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 zero 0 0 0 1 1 1 1 0 and okay, so this is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. And let's say the function, from the function it is 1 1 1 1. Function, it is like this. So practically what I'm talking about is f w x y z equals sigma of m 1 3 5 7 12 14 8 10, and we want to now group it. So one group would be this, Another group would be this one. So this is equals sigma m of 1, 3, 5, 7 or sigma m of 8, 10, 12, 14. Now, how do I write the first group? This one. Now again, we look at the variable which is constant. Okay, so the x belongs here, w belongs here. Look at the row. Now we see the x varying, but w is constant at 0. So if a variable is constant at 0, we write the inversion of that, like w bar. And here in this group, z is constant at 1. So it becomes w bar z. And then comes to the other one, this part, sigma m 80, 8, 10, 12, 14. And for that case, we see the w is constant at 1. So that becomes w. And between this column and this column, we see that z is constant at 0. Other y is changing 0 and 1, so it becomes z bar. So it's practically, this function is, this big function is optimized and reduced to w bar z or wz bar. In fact, this is nothing but an XOR between w XOR z. Question?
Professor,
Yes.
could you go back one slide, please?
Back one. Okay, sure.
So you made two groups of 4, right? What if you just, what would the equation be if you took just two groups of 2?
This one? Okay.
Yeah.
So let's say if you don't have two group of 2, then, group of 4, if you don't use the x's, then it will become like f w x y z is this group 5, 7, right? Which is w and x constant at 0 and 1. So w bar x and z, or now look at this group, which is w and x is constant at 1. And then you have z bar. So that becomes your optimized or reduced function.
Thank you.
Okay, so see, like if we don't actually consider the x's, we have like more functions to go, right? And later we'll see that each Boolean function becomes a logic gate or logic electronic component or operator. So if we did not consider x, then we had like 1, 2, 3, 4, and 1, 2 inversion operation, and 1 OR. But in this case, the other one where we actually considered the x, we have 1 and 2, 2 and 1 OR. So definitely this more logic operation means more electronic component to be put into that circuit to realize that function or implement that function in the electronic circuit. That means it is more costly. That means no one is going to buy your circuit. That means your business is doomed. So that's why it is important, like to optimize very carefully and make less number of electronic component as much as possible so that you can keep your circuit cost into the market competitive. Question? Okay. So that's the one. Okay. Maybe this is 8 o'clock, half an hour. Let's take a break, 5 minutes. Then we'll be back after 5 minutes.
So for anybody still here, that's the optimization of K-map optimization, is trying to reduce the amount of commands that you have to use in the end.
Yes, exactly. That's the K-map optimization.
Okay.
Okay, 8:06. Let's come back and maybe let's do some pop quiz. Okay, lecture 1 to 3. Go to your canvas first. Okay, go to your canvas and find out there is a pop quiz 1 in quiz section. And I am going to share a poll which tells you about, which asks basically once, like there's a password protected quiz, 10 questions, 10 minutes. But once you are there to enter the passcode, you need to click yes onto this poll. Just hold on. Then I will share the passcode once everyone is ready. So this one, launching the poll. So go to the canvas, find out pop quiz 1, and you'll get into a point where you need to enter a passcode. So there are 86.
So you want us to click take the quiz before, like, right now?
Yes, yes. Take the quiz and it will actually give you a password prompt. So once I see everyone is actually said, yes, you are ready to answer a passcode quiz, then I will actually launch another poll with the passcode so that you can enter and then mark that launch, like that poll.
Will we need any like hexadecimal calculator for this quiz? Like
I don't know.
Okay.
Probably not. Like even if it is more like a theoretical perspective. If you can, yeah, it is basically almost MCQ style. Maybe like little problem, but you can do almost on the mental side if you practice enough.
And is this extra credit?
These are all part of the bonus point, which is like total 10% marks.
Cool.
This is nothing
Thank you.
like 5 point. These pop quiz, but it will grow up, right? As we go along, progress on the semesters. So it will help. It will help at the end of the day. So 82 of you said you are ready. Hey, 2 of you said no. What do you mean by no? Can you explain?
I thought
Or it is
meant,
by mistake?
I thought you already gave the password and I didn't know what it was, so I said no.
No. I haven't give the password yet. Like, if you are at that page where it's asking for the password, just hold on. I want to see that every 86 of you are ready to enter the password.
Will we be able to use our notes?
Yeah, it's all open book, open note, whatever things you want to do. 10 minutes, 10 questions.
Open discussion? I'm assuming not, but I just wanted to make sure.
Not really. You don't have enough time, 10 questions in 10 minutes. 1 minute per question. It's kind of a rapid fire round. I'm waiting for one more person to go and vote that they're ready. I don't know what is going on with one more person. Anyway, let me end the poll and I'm starting another poll which has a passcode. Okay. In the poll. Yeah. Polls. Okay. Quiz password. Okay, here it goes. And let me go to the moderate quiz. At least I see some of you could enter into that quiz. So if that works for you, just hit yes for that poll so that I know everyone is in. I'm turning off the videos and muting myself. Just 10 minutes. I'll be back after the quiz. By the way, I'm here. I'm just muted. So if you need my help, just let me know.
Hi, I'm sorry I got back late. How do we get access to the quiz again?
Go to the quiz in the canvas. In the quiz section, you should be able to see a pop quiz 1.
Oh, I see it. Thank you.
Rebecca, I see that you were in the waiting room. There is a pop quiz. There is a poll with the pop quiz password. Can you please go into the canvas and see if you can access it? And I see that you have just joined. So did you have a chance to go for the quiz? Shian, you might want to go to the canvas, go into the quiz. On the ongoing poll, there is a password to enter that. Quiz being concluded for many of you, seems like. Let's see. Okay. Maybe a couple of more minutes. Okay, so I think most of you are done. I think two of you started very late. Please note next time I won't allow this much late in starting. Everyone need to start at very almost similar time. I understand there can be some like internet problem or something, few minutes here and there, it's fine. But you cannot really join late and attend to the pop quizzes. Next time I won't be allowing that. This time I'm letting you go.
Hey, Professor?
Let me see. So you guys cannot see your score, right? So far, or can you?
No.
No.
Okay, let me
Uh,
see.
Hey, Professor?
Yes.
FYI, there was a question where what I'm pretty sure was the right answer had a duplicate. Like there were two same. There was the same answer twice.
Okay, yeah. So basically, those cases, please send me an email. I'll take a look. Like these quizzes, I'm setting up like fresh new, so there can be some problems in the question. So if you think your point was deducted wrongfully, just send me an email. I'll review them.
And you're gonna unmute the grades at some point so we can actually see.
Oh yeah. I can do that always.
Oh, cool. Thank you.
Okay. Let me see if I can share the quiz statistics. How did the class? Okay, here. Okay, cool. Let me share quiz. Okay, here. All right, this is the one that class performance. I can see it's mostly on the 70s%, average 74, high 100, low 25, 20% with the standard deviation of these. So, and probably you can see these quizzes too, right? So basically you can look at that, that statistics yourself, but this is overall performance. I hopefully next time these numbers like average score will move up more like 85-ish or 90s. Let's hope for so. And I am going to open the, let me see if I can open the score for you. So any questions so far? No? Okay. Can someone check if you can now see your score and answers?
Yeah, it works.
Works? Akash?
Yeah.
Okay. So it should show you the right answer also and some sort of explanation. So if you see any discrepancy, any issue, just send me email. Okay, so I can always go back, review, and adjust your score. Okay, so what else? Any question? I don't have anything to discuss tonight for you. It becomes like quiz this weekend, Saturday, but it will be available from Friday morning. Those are, please make sure you study those quizzes. And project one, due date is upcoming, maybe next week, is it? When is it due?
16th.
16th, right? 16th.
So a week from today.
Yeah, a week from today. So make sure you have both report and implementation ready and uploaded as specified. So those two big things coming up.
Mr. Professor Patra,
Yes, Anjali.
I think on one of the questions, like he said before, there's two of the same answer.
Yeah, send me email. Yeah, send me email. I'll review. Maybe
Okay,
tomorrow I'll review those cases. Or maybe over the weekend. Don't worry.
Okay, thank you.
No problem. Okay, all right. If there is nothing else, so let's stop today, and so that you get some time for projects and studies and all this stuff. And good luck for the quizzes.
Oh, Professor?
Yes.
I have a question about the quiz. So this is just to confirm. Is for the quiz, is it open book and open notes and just like this one? Just like the pop quiz?
Exactly.
Okay.
Yeah.
And
the purpose of the quiz is to make you study and look at it where you're weak at, which part of the study, and then you go back, study, and come back strong. That's the whole purpose.
all right, got it. Thank you.
And remember, like these quizzes actually needs you that webcam-based proctoring and the, what is that called? Responders lockdown browser. These are like more formalities, and make sure you are yourself actually attending those quizzes.
Oh, hey,
You
Professor,
can use open book, open note, anything like that's fine.
On that note, so if you want to use it that way, it basically just makes it so we have to use a second device for notes. Like, I don't know if there's
Or
any
you
way
can
to.
print, or you can, yeah.
Yeah, but okay. So, but yeah, just FYI, like, because it basically makes it so we can't actually leave, like, it locks us down. So, but that's as long as you're fine with us using a second device, then cool.
Yeah, that's fine.
All right, thank you.